Good afternoon and welcome to Get Off Your AMF and Don't Rest on JSON. Our speaker today is Dan Kirkendall. He's a co-CEO and CTO of NT Objectives. He manages NT Objectives software development and handles NTO's relationships with several partner companies. He has an extensive background in web application development and security. As part of the founding team, Dan has been involved in methodologies and design of NTO's flagship product since its inception. Please help me welcome Dan Kirkendall.
Thanks. So anyway, I've been in this space for quite a long time. I started off on the development side of things, but I've been playing in this space. I do some podcasting and open source development. And over the years, I end up seeing a lot of the movement of how things are trending. And that's really kind of what I'm going to be talking about today, is really what I'm seeing as some of the trends that I'm not sure enough people are really paying attention to at this point. This changing landscape is kind of allowing us to put attacks into, against the classic stuff that we're all used to in web security. All that stuff applies into these new areas. I'm just going to kind of walk through some of that. So the changes here, we're used to this stuff. I mean, this is kind of fun. It's a web security conference, so everybody should be pretty familiar with the basics. Most of the attacks are, that are kind of can be categorized in two different ways: against the backends themselves and against the customers. And I'm going to focus mostly on the backends because that's really what we're seeing here in what I've been playing with. So part of what we're dealing with is the changing landscape, moving away from just classic HTML-based applications. We got RIA, or rich internet applications. That could be Flash, Flex, Silverlight. Also some just real heavy AJAX applications, the Gmails and Google Calendars. While they're HTML-based, they're very dynamic. They got a lot of activity going on behind the scenes. We're not just dealing with the name equal format model, and I'm going to be talking about that a lot. That's not what we're seeing for the back ends to power a lot of these rich internet apps. A lot of that could be AMF. That would be for Flash apps, REST, JSON. I'm going to go into each one of these and really kind of explain out what they look like and how they're still wide open to being attacked. And one of the other problems here is that there have not been tools to help. So, we're changing that with our tool, but this is, I'm not really talking about our tool, but this is an area I've seen a big gap. So everybody should be manually testing these things. Very few people seem to be. So here's what we end up seeing, right? The classic web apps are, in the green bubble there. That's kind of what we've been seeing for a very long time. These web apps are HTML and JavaScript based. They kind of go through their programming language, which has all the business logic, should be validating the data, escaping it, all that sort of thing. And then eventually you're dealing with the database on the back, right? The mobile-friendly web apps are very similar. They're just the HTML that outputs out of these things are, designed for the smaller form factor. And so those can be handled by traditional tools. But then when you're dealing with AJAX apps, some of them are HTML-based. The start of them are based on the HTML structures, but then behind the scenes, they're making these XML HTTP requests and getting more data. Those requests are not really always in name equal value pairs. Those could be JSON, REST-based. We're seeing some different formats there, and that's what we're really going to be digging into here. We also see AMF for Flash apps, Flash remoting. That's the Adobe messaging format. We see the mobile apps like this, or the orange bubble there, true mobile binaries that you install on the device. They're often making requests to get data. And that's again, we're starting to move into this half on the right where there haven't really been tools to help you solve the problem. And what we see there is that those are thin APIs in many cases. A lot of people are in a rush to build these mobile apps, build these, Flash games or whatever, and the business object layers get very thin. They're almost just a bridge to the database. So I end up seeing a lot of really interesting, good findings here. Tools, again, have fallen behind. This green line is kind of, your older application structure, and scanners have been very good at finding vulns in there, but as we've been moving up, the automation is really just falling behind. Again, we've been solving that on our end, but this has kind of been the trend in the industry that I've seen. So let's just baseline everybody. Again, I'm assuming most people should know how SQL injection works, but I just want to baseline it and kind of get you to see how this works in the other formats as well. So the basics of standard SQL injection attacking, you've got your name equal value pair. That parameter is going to be used somewhere. It's could be either on the get or the post, but the somewhere it's going to use that data, right? Somewhere behind the scenes in a lot of applications, let's say they're not using stored procedures, behind the scenes they're going to be taking and creating a SQL statement with the data, right? So the name parameter here is going to be replaced with the data coming in. So what we end up seeing is, in many cases, the developers aren't doing the right thing. They don't do the right escaping. And that data, if it comes in with a single quote, I'm going to be creating an invalid SQL statement, right? All very basic stuff. They should be escaping it. If they do, no problem. But we know they don't, right? That's why we all have jobs in this space. Once you have those vulnerabilities, then it's all about having fun with it. If I can do this on a login page, it becomes very fun and interesting because I can bypass authentication and sadly still see this very frequently. But this is all the basics of SQL injection. I've got a little video here of a little test app. I created multiple formats of this thing, or my team did anyway. And we've got multiple formats. This is a standard web app. Up on top, you can see the URL, ID equals 2. So we'll create some traffic here. And then I use Burp Suite a lot. It's one of my favorite tools. So, for manual stuff, it's fantastic. I don't know. How many people use Burp? Yeah, everybody. I'll have to tell Daffod. Say, yep. Anyway, so here I'm going to send this off to Repeater. And, right here you got ID equals 7. Very good. So, the response here, it's maybe hard to read, but on the bottom it's about 4,000 characters, okay? Standard stuff. We got, we'll put a little single tick in there. And create an error, get an error response. Okay, all the stuff we're used to dealing with here. That's about 8,000 characters, but it's going to have some error strings in there. Okay, and what we're going to do is just, again, I'm baselining everybody so you could kind of, this is the stuff we want to be seeing when we're doing attacks. Well, if you want to find a vuln. So, then we could do an or 1 equals 1 type of attack and just see if we can get all the records from the table. Okay. So it's going to proceed to go ahead and do that. We'll have to add the little plus sign. I wonder why the video seems to be playing slow. No, and it stopped. Something was going wrong there. Sorry about that. Anyway, I'll skip this one. I've got it, I could play it here, but this is all standard stuff, so I'll skip it. Okay, so how things are changing, okay? The changing landscape here. Let me get this video out of the way. Now we're not just dealing with name equal value pairs anymore. We're dealing with these other formats that we're seeing. It could be, AMF is going to look like binary data in the post field, okay? In the post section of the header or the request, you're going to see the AMF traffic is binary. You're going to see REST-based traffic, JSON. I'm going to kind of explain each one of these for those of you that may not be as familiar. AMF, or ActionScript Messaging Format, or Adobe Messaging Format, is the heart of Flash remoting. This is used by online games. I see all kinds of stuff using it. Even some login routines. They'll like load up a Flash app to log in, and it's going to send off stuff and then eventually get you logged in. There's a couple different versions. They're very well documented, the AMF formats, and there's libraries in just about every language for parsing these things. So what ends up happening is you have like a Swift file that's going to load up, and behind the scenes it's going to be sending this data, right? This is just a binary object. It's very easy to decode this thing, and Burp actually has some built-in mechanisms for doing it. So you can decode it and see the data, okay? There's the object represented as in a tree structure. But you can see there's the strings, right? Admin and junk. Well, it's very easy to modify those and send off requests against the back end and see this actually be exploited, right? So here's an AMF version of our app. So I'm going to switch the video. I'll do it here. I like VLC better. All right, so we're sending some traffic. You're going to see here's the binary garbage there, okay? Each one of those different requests, but I can now go ahead and decode this thing. Okay, there we go. We got our string ID. String is that's the ID field, but that's the value of a 3. Okay, very cool. I can go. Here's the value of a 6. Okay, this stuff can be seen. What I see a lot of people doing is they see this traffic, they have no idea how to deal with it, and they just ignore it and move on to something else. But there's some really interesting stuff that you can find when you start digging into this. Okay, so I'm going to go ahead and send it over here to a repeater. Let's do the same sort of thing. We'll do a single quote type of attack. Send it. We're going to get an error response. It's packaged up in an AMF format, but you can end up seeing somewhere in there, you can actually see the actual error strings. Okay, I could also decode it, hit the AMF tab and decode it and see it in cleaner format, but nonetheless, you know what's going on if you just kind of browse this thing. Same here. So we'll do an or 1 equals 1. Right? Well, we're going to just kind of repeat. The same attack is going to be able to be possible in all these new formats. And these are all new delivery mechanisms for the payloads that we're all used to. All right, so now I've got a very large response. This is a bookstore, so it's just giving me the records of every book in the table. Okay, very fun stuff there. Okay, so the next one, REST. REST is more of a style than an actual standard. It's one of these things where you kind of know it when you see it, but it's kind of hard to define strictly. What you're going to be doing is there's different ways you can make your requests, and then you're going to get responses back. And usually it's supposed to be kind of human readable to some extent. A lot of people will see RSS feeds, Atom feeds, send calendar files. Those are generally considered RESTful output formats, okay? Getting those could be done on a URL, right? I could have making my request for the data, I could do catalog item 17. That's a RESTful URL structure. Some people also consider that like an SEO-friendly URL structure. You may see, a good example is if you're going to get an RSS feed off of a WordPress blog, you would do /feed/RSS, right? That's a RESTful request to get an RSS feed. Okay, we see this stuff in our, in what we're dealing with, and we also see Ajax apps will often use them and send XML requests. So again, this is a very RESTful format where you've got your post resources and then catalog, ID 17, right? Different way of looking at it, but you're going to see it in these different formats. Doesn't really matter what it looks like, just, it's easy to comprehend when a human looks at this stuff. So again, we can attack these as well, right? I can come in here, we got a RESTful version of our bookstore. So we'll go ahead and send some requests off. This one's actually sending XML requests, okay? That ID equals 1 there, 2 there, okay? Same kind of thing. So we'll go ahead and there's ID 7. So we'll go ahead and send that off to repeater. Send it. Okay, it's a small little XML response that we're getting back. Okay, 355 characters. I'll just quickly do a or 1 equals 1. Send that off. Now it's 7,000 characters, and it's going to be all of the records out of the database. Okay, same payload we're used to, just delivering it in a different format. And then really, to me, the most important format that I've been seeing is JSON. JSON was initially created for Ajax apps. It was really created for JavaScript and to parse in JavaScript very easily. It can be sent as a get parameter, but most of the time it's going to be sent as post data. It stands for JavaScript Object Notation, which is a dumb name, but JSON's kind of a cool name, so we'll stick with JSON. JSON is a textual format. You can store the same type of data as you do in XML in a very compact textual string. Okay, this is a nested array. Is basically what it is. A nested list of data, and it can be as nested as it wants to be, just like XML can. The one on top is nicely formatted, so you can kind of see that nature. But normally you're going to see it all in one line, like on the bottom. Okay, that's generally going to be how you see this data. So here we go. We got our little bookstore again. We've got a JSON version of it. So let's go ahead and do some JSON requests. So we're making generating some traffic here. So there we go. Here's our requests. They're outputting JSON out of this app. Okay, it's being done with JavaScript. Very easy to do. So we'll go and send this to repeater. And let's do the same sort of thing here. So there we go. I got ID 5 there. Now again, as you deal with each of these formats, you've got to be able to handle the fact that you've got to look at each one and identify how to put your payload in there and format it, in a way that's appropriate to each of these, formats. But nonetheless, I'll go ahead and do a single quote. Let's generate an error. Here we go. So we got an error. We know that we're causing a problem. Okay, unclose quotation mark, whatever. So let's move on to doing an or 1 equals 1 type of attack. And now, of course, we're going to get a very large response. This is some 65,000 characters, and it's going to be each of the books, all the way through the list, okay? So this is very repetitive, but the point here is that your payloads that you're used to are very valid and very useful. You just got to learn how to use them in these different formats. And so now let's talk about mobile, okay? Because in mobile, JSON is very prevalent. Most of the tools that the toolkits, they use JSON. But let's just kind of cover the whole mobile app space, right? The apps themselves, the markets are just kind of wild. Pretty much anything can get in there. It's very easy to toss an app in the mobile app stores, okay? A lot of people assume that the transport protocols are secure, that it's going over the mobile network carriers. That's hard to there's a large investment if you wanted to actually set up a fake tower. The hardware involved, you're a couple $1,000 in. Not that that's a big deal, but normal people aren't going to just be buying these things. There's problems with authentication. A lot of these mobile apps end up using the MEID or the IMEI. They use these things. Those are like the social security number of your phone. Okay, they're not intended to be secure identification. They're just the ID off the SIM card is basically all it is. But people use that. And one of the problems is that very few of us in the security community have really started paying attention. A lot of people are focusing on, on the device in your hand, on the mobile phone and the mobile app that you install. But, I'm trying to get people to look beyond that, right? Everybody's focused here. Look beyond it, because on the server is actually where all the real data is. Most of the data is not available in the app itself. It's got to go off and get that data. So, there's easy ways to do it. You can get the data. I'm going to kind of go through a couple quick ways to do it. You could certainly run the app in an emulator. That's one way. Or you can set up proxying to actually get data. And then again, you have to look at the formats. Most of it's JSON. We see some REST-based stuff. And there's often a mix. You may have a a normal, GET request with name equal value pairs as the request format, but then the response is going to be JSON. Usually JSON's involved in one way or the other, so you got to get comfortable with it. This is, request that I'm coming out of Words with Friends when it's grabbing its advertisements, right? That's, what do you see when you see that? That's JSON, right? That's the stuff. You got to get comfortable with these formats. Most people I talk to don't get it. They're not really paying attention to these different formats. So, here's my mobile app version of my little bookstore, okay? This is an actual real app. We had to build out. Is it going to play? Nope. Let me do it. All right, here's my little bookstore app. I'm going to click on some books. Okay, let's generate some traffic here. All right, so here's the traffic in Burp now. I've set it up so I can record that. I was actually running it on an emulator in this case. But again, we have the data here. It's all they're in that same format. I can do the same sort of things. Now at this point, I don't need the mobile app anymore, right? Now I know what the traffic to its back-end system is. So forget the mobile app. I'll just sit here with, a manual tool, maybe some Perl scripts, Burp proxy, and manually go in there and start beating up the back-end server. So here, I'll do a 2, see my record, and then I'll do my 2 or 1 equals 1. All right, so anyway, there you go. It worked against the back end that's powering this mobile app, okay? So let's talk about some real world stuff that I've been doing as I've been researching this app, this out, okay? I've been looking at a lot of mobile apps and playing with some of these things, and this is really where the fun part is. Simple things. This is one actually we just found a couple days ago, so I tossed it in here really quick. This is the AP Mobile, which is the Associated Press, their mobile app, okay? Right here, it has this is a RESTful request, but it's using name equal value pair structures, okay? Nobody knows this exists unless you start looking at the traffic from the mobile app, right? These are there out on the internet, but nobody's testing them, right? So you see the user agent is AP Mobile. That's the, what's kind of nice is all these apps end up identifying themselves when you look at their traffic. But the normal response is some JSON response, okay? So of course, when you see this, what do you got to do? Toss in a little single quote, and then of course, they're very nice about it, and they give me the entire SQL string, right? Down at the bottom here, you see that the value is used as the limit, right? So now I'm going to start having fun, Now, okay, what is it? I'm going to really steal an AP's site. I'm just going to get news earlier, maybe? I don't know. But nonetheless, this is stuff that we're not seeing if we're not going in here and looking at these back ends. This is basically what I've been doing is hanging out at the mall, okay? I wanted a place where I wouldn't get a lot of laptop traffic, so Starbucks didn't work. I wanted a place where I'm just mobile traffic only. So I brought my little Wi-Fi access point. I had put DDWort on there. You can use whatever one you like, OpenWord or whatever, okay? Got that going. Put in a couple IP table rules to force the web traffic through my laptop, which has got Burp running on it. And then I've got my little T-Mobile hotspot, so I'm really delivering internet access, okay? What ends up happening is I'll end up broadcasting as like ATT Wi-Fi, Panera, H Honors, whatever, Linksys, okay? What ends up happening is devices connect to me, okay? And mobile devices, and what the mobile carriers have been doing is they set up the device to prefer Wi-Fi to get the data off of their network, okay? So anyway, I'll have this set up, and I'm just sitting there at the mall, hanging out. It's a good time. And people are connecting, and I'm starting to see some very interesting stuff, okay? I can collect MEIDs. A lot of apps send the MEID as a parameter to their app to identify the device, okay? That's not a good thing, and I'll get to some good examples of why. But anyway, I can start collecting these social security numbers from your mobile device, okay? We also see tokens. These tokens are, you know, when you're dealing with a mobile app, think about how often it asks you to re-log in. It's very infrequent, okay? Once it authenticates you, people don't like to have to log in over and over again on this darn app on their phone because the keyboards aren't very friendly. It's also why people with their mobile apps generally have very weak passwords because it's not a friendly keyboard. So we end up seeing some very interesting stuff here. You know, so I can start collecting session tokens. Those tokens don't expire. So again, I go home and I could be them all day, right? And probably for the next months or 2 months or year, whoever knows, I'll have access to their account or whatever, their system. I also see passwords. Believe it or not, most mobile apps are still using basic auth, okay? Plume is a good example. Fantastic Twitter app, but think about this. They connect to me. What's, you know, behind the scenes Plume is running. It's going to immediately go out and try to get new content. Well, it's sending basic auth credentials, so I could base64 decode that, have username and credentials. Now, that's not always their Twitter password because this app actually goes through Plume's server, and then Plume is the registered app with Twitter. But I've got their Plume account, and they're probably using the same password over and over again, right? We see that. So those are kind of fun. I get a lot of passwords that way. I also see even the apps that are using SSL, well, a lot of apps don't use SSL at all, and then when they do, they don't necessarily even require a valid cert. I don't even have to get to the level of even dealing with beef. It just goes, right? I don't have to do anything. Actually, there's while I was here, so this is what, yesterday or day before? Okay, I just saw it on Twitter. The Register actually just had an article, and they found like over 1,000 apps that were totally using SSL wrong, okay? It's very easy to get it wrong, especially on mobile devices, on the mobile apps. You know, servers have people testing, you know, scanners. Network scanners will test SSL implementations of, you know, the web server, but not really the app. And not, you know, it's not like with browsers where, you know, the browser makers are generally up to speed on all this stuff. People making mobile apps, don't trust them. So some of these aren't just situations where it's very easy SQL injection. Some of them are some business logic. So here's a few examples that I was having fun with. The first one I was doing with my, I was playing Words with Friends with my cousin. This was, I found like well over a year and a half ago, and it doesn't work this way anymore. So there might be other vulns, but this one doesn't work. I was watching the traffic, and one of the requests, when I went to put my letters on the board, it made a dictionary lookup. Okay, it doesn't have a very large dictionary local, so it makes a request for that. Okay, and then the response comes back and tells me that it's a valid word or not. So of course I saved that. Right, put a valid word. I got a positive response back. Then I went ahead and dropped all 7 letters on the board. Right, just in whatever order. Sent it again, and it went out, and I intercepted the response, and it said it was an invalid word, so I put the valid word response in there. And then the next step is for it to actually drop the letters on the board and submit it so that it gets to the other person. So of course my cousin's freaking out because I've got, you know, garbage, and he's like, how did you do that? So it was a lot of fun, had a good time just kind of messing with them, all right? So, you know, I'm Scrabble champ. Some other ones, MJ Keith, he's not at the Denim Group anymore now. I guess he's at Stack and Lou. But he's actually did some of the research that inspired me a lot to get into this space. So a lot of props to him. But I'm going to give some of his examples since he's not here. My Backup Pro. This one's a lot of fun. My Backup Pro is a tool for actually, you know, saving all of your data to a server. Okay, and it's secure. It's using the same security banks do, SSL, right? But it doesn't require a valid cert. That's one problem. The other is that it asks you to log in. So you put in your credentials to log into the app. Well, when it actually sends it to the server, it just uses like I see these basic auth credentials in there, and I go, okay, at least it's authenticating. But then I decoded that. That wasn't my credentials. That was hard-coded, fixed stuff they had put in the app for everybody. Okay? It's just using the MEID to identify me. So remember all those MEIDs I collected at the mall? I could just start polling and see if I get some backup data, right? Address Book Pro. Ask for credentials. Doesn't even bother sending any credentials to the server. I guess my backup pro is not much better, but it convinces you that you're secure because locally you're having to plug in a password to get your data or to do a backup, but it's pointless because it's just protecting you from you. Stupid. Pwn on the go. This was a talk that MJ Keith had went over, and I've been playing with this one. This was a lot of fun. You're all familiar with Bump, all right? Bump is an app where you can share contacts. It's really great. You know, sales and marketing people love this thing, okay? Because you're at a conference and you're like, oh, I like you, let's talk later. You know, you bump your phones together and it shares contact data. The way it does this is that the two devices don't actually directly communicate with each other, okay? When you bump, each phone sends data up to the server, okay? And based on timing and location, it matches you up. So what happens is the device actually sends its time, right? Or it sends the time, and they also have the time, but it sends its GPS coordinates and how accurate it feels that those coordinates are, right? Because sometimes it may not be getting GPS, it may be getting a tower signal or whatever, okay? So they let the app decide how accurate that is. But of course, they don't put any boundary conditions, okay? And there's nothing that really authenticates the devices, right? You send, it comes back, you send that you bumped, and then data comes back, and there's a status check, it kind of goes back and forth. But what it bottom lines to is that both people bump, goes up to the server, and they match you up based on these data points. Well, there's nothing to even control that it's a mobile app. I sit at home, and I got a Perl script that I run, and I say that I'm over the Moscone in San Francisco, right, where they do RSA every year, within an accuracy range of 3 miles. It's a big space, okay? And I'll just have that running. I got that running on one of my Linux boxes, and it just churns away. And what happens is, some people will bump, and I will get matched up, okay? Because I'm on a higher speed connection. So the data will, come to me, I'll accept it, right? And then I'll give them back a reject. So I'll get their data, they don't get mine, they get an error. Sometimes I'll even just do an error vCard, okay? What are they gonna do? They go, hey, that didn't work, let's do it again. Now they bump again. So now, just imagine I've got both people's data, because I accepted both of them, okay? So they bump again, now I'll go ahead and flip it, I'll give them each other's data back. But I can alter things, right? I have the vCards, I can do whatever I want. MJ Keith actually had fun with it. He actually was able to take and in the URL field, he put a URL that had an exploit against the iPhone Safari browser, right? He was actually able to get remote shell on the iPhone. Very cool, right? But even just as a data gathering, this is kind of cool. People are giving you full data sets, right? And you just sit there and, a Perl script, I'm going to get tons of data this way. Very, very fun. So anyway, the point of all this is really just kind of awareness, and I'll do the cheesy G.I. Joe thing, right? Most people don't know. I talk to a lot of people in the community. Most don't know how to get set up to start looking at this stuff. And that's really what I want everybody to start focusing on is these are just like, I do feel like in many cases that I'm in 1999 with web security all over again when I'm dealing with mobile. It's the same stupid stuff that all the mistakes we made, they're making all over again in mobile. They're in such a rush to build. Anyway, wide open to attack. We've understood these problems for well over a decade. And the SQL injection, how was that, 10 years? It's got to be more like 15, maybe 20. But apps are still vulnerable, and now we're moving beyond just web apps to these mobile where people aren't looking. It's a mess. And anyway, I just wanted to get you all aware of it. I think it's very interesting. I've been having a lot of fun playing in this space. And we've been building our scanner to support all these formats, which just means I get to play with this stuff more, and I'm enjoying it. So anyway, the goal for you to do is start looking at this traffic, okay? Just look at it like you do with your web traffic. Start figuring out how to either run the apps in the emulators or whatever, and get in there, learn the formats so you know where to, deliver your payloads. And then one other little note, by the way, WAFs are useless here. I haven't seen a single WAF at this point, and I've talked to a few vendors that are saying they're doing this, okay? But WAFs aren't handling these formats, right? I mean, unless they're doing the whole string and they're hoping to find it, if an AMF packet comes in, they don't know what to do, they let it through. They see some JSON string, unless they match against the whole string, they don't have parsers that are going to go through that nested thing and look at each of the parameters and what their values are. They have to look at the entire string, and WAF evasion becomes very easy at that point. So, I've been having fun with that. I keep talking to vendors, or the WAF vendors, and saying, how you've gotten JSON? Can you handle REST yet? No. Okay? They'll handle some XML. They're getting good with that, but the rest, they're kind of useless. Yeah, well, the emulators would be like there's dev toolkits that you can run the emulators, and for those, it's very easy, to use burp local. The other one is to do the Wi-Fi traffic. All right, if you could set that little environment up, $200-300 of hardware, get it all set up, and route the traffic through burp. What I do at home is I have a special access point that's set up this way, and then I take my phone and I disable the mobile data networks, so they're forced to send their data through the Wi-Fi, and that's how I end up getting more traffic that way. Any other questions?
How effective have you seen things like XML gateways, layer 7, in helping with this?
Yeah, you're asking how effective are the layer 7 gateways?
Yeah, or any competitive.
So basically the web app firewalls, like I said, they've been fairly ineffective. I haven't seen much of anybody supporting these formats. When you're dealing with AMF traffic especially, nobody. Some are, like I said, handling some XML, but not JSON, not AMF. Most of that stuff just goes right through because it's not a format they're used to. Anybody else? Anybody else started hacking these mobile backends yet? No? Anybody going to go home and do it? Do you have a question over there?
No, I was raising my hand.
Oh, okay. All right, well then I think we're done. Thank you for your time.